All right, welcome to our recap of day 4. So day 4, I handed out a piece of paper like this, and I asked you guys to very carefully look at the coordinates of the point and answer these 3 questions. What is x? What is y? And what is y over x for this point right here? And then I walked around and I gave you guys over 10 minutes. So if you want to take a pause and try to remember again. So quickly people came to the conclusion. They said, well, where are the axes? And I said, I don't know. They're not there. And they said, well, can we just make them up? Can we just start putting like little tick marks over here on the bottom, right? Like tick, tick, tick. Nope. You can do this without making marks. You can think about how quantities are represented. I did give you the hint that this is very necessary, that both axes are scaled the same. Right? In other words, this isn't a graph that's kind of been squished vertically or squished horizontally. And so we finally came to the conclusion, what is x? Can't tell. We have no way of telling. What is y? Can't tell. What is y over x? You can tell this. So I asked people to think about it. Alright, so in the end, I got 2 different numbers, main numbers. I got for part C, I got 2, or I got 3. And now let's look at what's actually happening here. So what some people did is they saw this and they didn't really look at the question. What is y? Right here. What is y? What is x? Instead they just kind of drew a little up and over, which is okay because you've been trained to do that. And then they said, oh, well, this length right here is about twice as much as this. Well, that doesn't have anything to do with the question that I asked. So instead we need to look at y and x because these actually are changes that we'll talk about tomorrow on the very next day, on day 6. So I'm going to clear all this. And instead, let's look at what represents the x value. This right here, right? Isn't it how far off to the side and in fact how far to the right you go on a graph that determines your x? Yep. And then what about how far up you go from the x-axis? Isn't that your y? Here's my x, here's my y. It's not from here. It's very important to understand that if I'm talking about x, it's distance to the right of the y-axis, and y is the distance above the x-axis. And now if you take this amount, and you try to fit it in, you'll see that it fits in about 3 times. And so weirdly, even though we cannot tell what x is and we cannot tell what y is, we can estimate that y over x is approximately equal to 3. After this, we went on to talk about the larger meaning of everything that was done right here. Next we did the changeometer. If you remember, we had us hold one hand still and move our other hand up and down to mark the y value of different functions. But I'm not going to show this in this recap. It was much more important for setting something up for what's going to come later. So don't worry about that, and I will review it when we use the changeometer again. So now we talked about shift 5. It's really easy for people to start with this idea that graphs are curves, right? They look like a piece of wire or a string that you lay out. It's a one thing. From there, we need to move to the idea that graphs are infinite points. Infinite points, all of which satisfy some sort of equation that make it true or balanced. Now we need to go even beyond that. Each point represents 2 quantities, right? It represents the x quantity by means of, let me draw a graph up here. It represents It represents the x quantity by means of how to the right it is of the y-axis, and it represents the y quantity by means of how far above the x-axis it is. And so in this one thing, in this one point, you have two things actually being represented, two different measurements of the x quantity and the y quantity. And so next I gave you an activity that kind of pulls this all together, because this shift is really one of the hardest ones to practice or to test. It more comes out when we're working with other things. So I'm going to clear all this information. And I asked everyone to open GC, and I gave them this picture. As you can see, the first line is typed right here, and I asked everyone to go ahead and type that. Y equals 0.3x squared minus 2x plus 4. If you graph that, you get the purple line. Then what I asked everybody to do was go ahead and also make the dots show up right here, and I told them that it is at x equals 2. I also want you to do this line. This line represents the x value or the x coordinate, the length of it. And I want you to do this line whose length represents the y value, all of this point right here. And so I gave people some time to work in groups and try to write this down. And I also strongly suggested to use open expressions, because that would make the next part of this activity so much easier. So if you want, now is the time to pause and try to do this yourself. Alright, so let's look now at what happened. So here I'm starting with just the graph. Let's move this down. I use Control Enter, and I want to, again, put a point on there, Control 2. Well, what tells me about this point? I know that the point has an x coordinate of 2 right here, x2. And what's the y value? Well, the y value is what happens, the result of taking 2 and plugging it into this equation right here, right? Where you just plug 2 in for the x's. So because of that, what I did, I'm going to clear this note, is I wrote 0.32 squared minus 2 times 2 plus 4. Alright, so here's the input and the output that correspond to this equation. Hit enter. Alright, I got that point. Next, we want to draw a line representing the x value. Alright, so this is the line that I want to draw. I'm going to draw it with my pen for a second. What exactly is happening? Good. I want to draw this line right here. Okay, well, what do all these have in common? Well, they all have the same height above the y-axis, don't they? So they all have the same y-coordinate. So I have y equals, and what is the height of this? Well, the height of this is the same as this y-coordinate. So it's 0.3, 2 squared minus 2 times 2 plus 4. I'm going to go ahead now, clear these notes and put that in. Y equals, and I can even just copy this. Good. That is what I wanted, except it's too long. What I really want to do, oops, come on. What I really want to do is get rid of all of this, right? I want to get rid of all of this on this side, and get rid of all of this on this side. So how can I do that? Well, this line, I want only the domain to go from the x-axis from the x-axis to 2. So if I come on up to here and I use the domain, there. Now I was now able to draw a bar representing the x value. If I clear this, now I can focus on the bar representing the y value. Here is the bar that represents the y value. How high is my point above the y-axis? Well, in this case, what do all of these points have in common? If I stop thinking about a line and instead thinking about it as a series of infinite points, right? So here's a point, and here's a point, 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 here's a point. What they all have in common is that the x-coordinate of all of these points is 2. So coming up here, x equals 2. Oh look, that gives me my line. But again, I only want part of it. I only want this part of it. I want y to go from 0 all the way up to, what's this? Oh, well that's the y value of the function when x is 2. So I can go from 0, if you look up here, 0, y, and I want it to end when it's 0.32 squared minus 2 times 2 plus 4. Alright, as you can see now, we have written the equation for both lines as well as plotted the point. The last thing we did today was we started to work on animating it. That this time had this little n bar. And look, now the x and y bars are animated as the point moves along the curve. And so here was my hint, and I believe this hint is only necessary for Macintoshes and not for Windows, but everyone can do this. If you go to that next line and you just type it in, you don't have to do anything else. That will make this show up. I then asked everyone to click on n and choose n to go from 0 to 10 in 100 steps. And then I said, alright, now figure out how to animate it. You already have, come on, there we go. You already have this first line. You already have the graph without it being animated, right? If I move n to 2, close to 2. You already have this. How can you make it animated? And I gave you some time to work on it. So right now is the time to pause if you want to work on that. Alright, so here is now when we went ahead and went over the solution. How do we make this point move? Well, as n goes from 0 to 10, we can also force the point to move by making its x value change. And again, I had some people that said, oh, I can put n for 2. Very good. Let's see what happens when we just do that. Okay, so for the point, the x value is now changing as this animated n value changes, but not the y value. So what can we do? Well, here's one of the strengths of open expressions. You know that you always want to calculate the y by doing 0.3 times the x squared minus 2 times the x. So now if you put in an n wherever the 2 used to be, now as n changes, it's going to calculate that for you. This right here is going to repeatedly calculate over and over and over again as n changes. And so now let's see what happens. The point moves along the graph very nicely. What about these bars? The bars are good for when n is 2, but they're not good for all the other points. Well, let's look at this bar representing the x value. I always want this to be at a height equal to the y value at that point. So I'm going to have to come over here and say, if I change this, now the y value will always change and that bar will move with x. Wonderful. Oh, but it's not long enough. It is not long enough. So how can we make it longer? Well, it shouldn't always go to 2. It should go to whatever the current value of x is. And that's n. If we change this to n, now let's see. Alright, now we have always a bar representing the total x value at any point, whose length represents the total x value. Let's go back and let's figure out the y bar. Alright, so this bar right here, its length represents the y coordinate. So how can we change that? Well, it should always be at wherever the point is, right? So it should always have all the x coordinates the same. So I'm going to change this to x equals n. Let's see if that works. Alright, it's definitely moving with the point, but it's not long enough. It should always go up to the value of y on the graph. What's the value of y on the graph? Well, that's where you take this equation and you recalculate it for the current value of x, which is n. And now we have something that works. Or we can animate the point and we can say here are two bars whose lengths represent the x coordinate and the y coordinate, because the length of the x bar is how to the right the point is from the y-axis, and the length of the green bar is how much above the x-axis the point is, representing the y-coordinate or the measure of the y value. And that's where we ended day 4.